Good morning, ladies and gentlemen. It's an honor to have the opportunity to address such a distinguished audience. I would also like to thank the organizers of this conference for having me here today. So today I would like to present the paper, Detection of Brain Tumor Using Fast and Robust Fuzzy C-means Clustering, along with support vector machine for classification. To give a brief introduction and an overview of the subject, so in recent years, along with the breakthrough of artificial intelligence and machine learning, improvements to the existing systems in place have been extensively studied, and there have been many applications in practice, especially in the field of healthcare. Now, one of the many applications of artificial intelligence in perhaps the detection and classification of brain tumors. Now, as we all know, the human brain is a delicate organ of the body which controls all the other parts of the human body with the help of neural signs. But when there is, a gathering of unusual cells or an unusual amplification of brain cells inside some part of the brain, this is what is called a brain tumor, and its presence can be fatal to human life. Consequently, a careful detection technique is needed in place. So today in neuroscience, we all know that the brain MRI is a comprehensively recognized imaging system, which is the most consistently used approach for imaging brain tumors and getting a view of its region. So moving on to the abstract and overview of the work that has been proposed in this paper. So like I said, in the field of brain tumor detection and classification, image segmentation is one of the vital steps for extracting and gathering huge amounts of information from the MRI scans. To deal with this, fuzzy C-means clustering algorithm has been the most acceptable and widely acknowledged method for the detection of brain tumor, but it has numerous limitations and constraints. So since the fuzzy C-means clustering algorithm is affected by noise to a great extent, local facial information is generally introduced as an objective function to enhance the robustness of the FCM. Nevertheless, a lot of times the introduction of local spatial information leads to a computational complexity that is very high in value. This is due to the iterative calculations of the distances between pixels located in local spatial neighbors and clustering centers. Hence, to address this issue, a new enhanced version of FRFCM, which is for fast and robust fuzzy C-means clustering algorithm, based on morphological reconstruction and membership filtering, has been proposed, which is significantly faster and more robust than traditional FCM. So, and furthermore, we have even incorporated support vector machine, which is the SVM model, to classify the brain tumor as either benign or malignant, which are the two types of brain tumors. But firstly, before getting into that, let's look at how exactly the detection of brain tumor happens. So firstly, to begin with, the local spatial information of images is merged into FRFCM by introducing morphological reconstruction to promise noise immunity and preservation of all image details. This also in turn removes the difficulty of having to choose different filters suitable for different types of noises in existing improved FCM algorithms. Consequently, the proposed modified version of FRFCM model is more robust for images that are prone to or have been corrupted by different types of noises. Now, morphological dilation and erosion have been two operations used extensively in this proposed methodology. So over here, as you can see in the equation, the erosion and dilation parameters contribute in constructing the modified image. Next, as part of the second step, the membership partition is modified by replacing the local membership filtering and making it dependent only on the spatial neighbors. So in comparison with the existing algorithms, the proposed model is simpler and significantly faster because unlike the existing FCM algorithms, it is unnecessary to compute the distance between the pixels with the clustering centers and local spatial neighbors. Hence, using this methodology, the presence of a tumor can be determined in a more efficient and precise way. So now moving on to the classification part of the model, it is important to know that unnecessary features used for classification not only increment the computation time, but also lead to excessive storage memory. Therefore, it is essential to reduce the number of features to overcome the problem that I just mentioned. So principal component analysis, that stands for PCA, is a proficient tool to reduce the dimension of a data set consisting of a large number of interconnected variables while retaining most of the variations that are important. So reduced dimension means a reduced feature set that can act as an input to the SVM model during the training part as well as the testing part. So as you can see on the screen, these are the steps followed to perform PCA as part of the proposed model. So firstly, the mean of the data matrix was computed. Then the mean was subtracted from each image. Then the covariance matrix was computed using the equation shown in the slide. Now after this, the eigenvectors and values were computed for the covariance matrix. And finally, the feature matrix was generated. Moving on to the next step for the classification of brain tumor, which is SVM. So SVM is support vector machine, and this we use for the classification of the brain tumor as benign or malignant. Now, SVM is basically a binary classifier based on supervised learning. So it classifies between two classes by constructing a hyperplane in high dimensional feature space, which can be used for classification. So whatever lies maybe beyond or beneath the line can be considered as two different classes or two different classifications. Now, depending upon the complexity of the MRI scanned images, they are basically two types of SVM. One is linear and the other is non-linear. So in linear SVM, a straight line or hyperplane is used to distinguish between two classes. But if we look into it in terms of a real time example of or using real life images, such as the one that we used in this paper for brain tumor detection, it does not happen that the entire data point or data set is categorized as per one hyperplane. So that is a hypothetical situation which does not happen practically in real life. Hence, we have used the non-linear SVM classifier to map the input pattern X into a higher dimensional space. So the non-linear SVM classifier is defined by the equation as shown in the slide. And based on this methodology, the brain tumor is classified. So now to give a final workflow and architecture of the proposed model, this is how it looks like. It starts from image acquisition, then morphological reconstruction is performed. The reconstructed image is subjected to membership filtering and FRFCM. Based on this, the presence of tumor is confirmed. And if it is a yes, then feature extraction is done using PCA, which, like I just said, was principal component analysis. Then the features are consolidated and normalized. And finally, the tumor is classified as benign or malignant. So this is an end-to-end depiction of the proposed model. Now, moving on to the actual implementation of the proposed algorithm. So the proposed solution was performed on grayscale images in two sections. Now, first was obviously the detection of the brain tumor, and second was the classification. And the results can be seen in the figures as shown on the slide. Now, various parameters and components of the images were defined in order to perform principal component analysis. Some of the features, if you can see in the table, are mean, standard deviation, entropy, RMS, variance, smoothness, etc. So all these factors were considered, and based on that, the principal component analysis was done. The results obtained from the PCA for 4 sample images have been shown in the table, as you can see. Now, the data set that we had used was BRAT 2020, And these 4 random images we have chosen in order to show the observations. Now, moving on, the performance measures for the proposed model for classification was done in terms of 3 factors, which is accuracy, sensitivity, and specificity. And as you can see on the screen, these are the values that were obtained. Now, in terms of the end-to-end model to achieve the expected outcome, the processing time observed was significantly low, reaching to maximum around 30 seconds. And in terms of the accuracy results, when compared to other existing models and systems in place for detection and classification of brain tumor, the proposed model shows the highest accuracy level. You can even see that in the table as shown on the slide. Well, this brings me to the end of my presentation. Hence, to conclude, I would like to summarize that in this paper, a system has been proposed for the detection and classification of brain tumor using MRI images. The methodology involves sequential operations to be performed, such as image acquisition, Gaussian filtering, morphological reconstruction, fast and robust fuzzy C-means clustering, and finally, support vector machine for classification. Now, based on the simulation on real-world images, the accuracy that was obtained was for malignant tumor, the classification accuracy was 99.02%, and for benign tumors, it was 99.67%, which is higher as compared to the existing models that were proposed. So with that, these are a few references for which we can get in touch later offline. And with that, I complete my presentation. Thank you so much for your attention and patient listening. It has been an absolute honor. Thank you so much.
Thank you, ma'am. Thank you for your wonderful presentation.
Hello everyone. Today I will be sharing my research work on neural image style transfer. With the current scenario of various devices coming into mobile pictures devices, we have a lot of multimedia content generation, due to which there is a lot of image generated, and from that image there are various things that people would like. Let's suppose there are a content image and a style image. Earlier we used to do a full style transfer from one image to the another image, which would take a time. But in our research work, what we did, we tried to segment an image, and then we apply the transformation of the color from one image, where the user selects that image, set that segment, and that transfer that image to it. Let me show you the flow of it. So this is our flow diagram, wherein the user selects a style image, and there is one content image. We run a deep lab segmentation model on it to obtain a segmentation map, wherein user selects the segment of a content as well as the style image. And on the style image, we perform a maximum rectangle computation. So in order to get the maximum rectangle which fits into the contour of that segment selected. The segment may be the selected segment may be kind of some zigzag or some other pattern. So we had to fit in the maximum rectangle in it, so as to we can get the tonality of the color from it, and from that color we would transfer to the content image, where the user selects which part he would like to transfer the color to it. It would be very clear from this image. Here, let's suppose the user selects the content image as this one. This conference people are listening here, and the style image from this row, and the color that has been selected is of the wall. Suppose he wants the color of the wall to be another. Currently, we don't have any functionalities or that can do this thing. So what we did was we tried to segment that and transfer the color from this image onto that one. Similarly, we have done for various things, but first we tried to implement this on the laptop version, which we successfully did. And after that, we also went on to the mobile version of it, wherein we optimize it. Wherein we optimize and latency to 7 seconds, which was a pretty good thing, because earlier all the full image style transfer would take 6 hours. So that was our achievement in this paper. And there are various things related to it that gives the user various capabilities, so that they can create their tonality, or their images, the kind of images they want to compose, or their kind of image, or they compose, or they want to synthesize. So I think that is from my side. Any question or comments I would like to take upon?
Thank you, Banu Mato, for your wonderful presentation.
Hi everyone, I am presenting my presentation on properties of zinc oxide and magnesium oxide nanostructure thin film. I have done my study under the guidance of my guide, Dr. Swati Arora ma'am. These are the outlines of my presentation. So the objective of my presentation is basically to find out the relationship between the optical band gaps with different composition of zinc oxide and magnesium oxide thin films. Also, we will analyze their structural architecture using different analyzing methods like XRD, SEM, and AFM analysis. So the motivation behind the study is nowadays nanostructure materials are very popular as they have high economic value due to their lower price of processing and minimum material reduces, thereby also solving the purpose. The thin films are also the nanostructured materials which have semiconductor kind of properties. For making thin films, we are using metal oxide. The metal oxides that we are using are basically known as TCOs, which have high transparent and conduction values. The metal oxide that I am using are zinc oxide and magnesium oxides. Magnesium oxide is basically used as an active material in zinc oxide thin films, thereby increasing its efficiency and making the band gap more tunable. So this is the methodology we are obtaining. In this, we will fabricate the thin film, and then we will analyze the structure of the thin film and its optical properties using different methods. So in the literature survey, we will see that in order to find out the relationship between the band gap and the different composition of our thin film, we need to find out about the absorption, the value absorption coefficient of different composition of the thin films, and later by using the Tock's law, we will find the change in the band gap with change in compositions of the thin films. So these are the materials I'm using, and these are their different properties. Now we will see the fabrication and characterization techniques. For fabrication, I had used electron beam physical vapor deposition method, in which the heated electrons are basically used in order it will vaporize our sample, and then it will condense our sample on the substrate, and all this will go under the high vacuum chamber. Now for analysis, we are using different analyzing machines like X-ray diffraction machine, in which diffracted X-rays are used in order to study the structure of the thin films. These scattered X-rays are recorded using detector, and then they are graphed accordingly. Another, we are using scanning electron microscopy. This will provide us more magnified FBAD and more higher quality of the image. In this, scattered electrons are used in order to get the image of the thin film to study its structure. Then we are using atomic force microscopy. It is a very powerful microscope that is used to study the nanostructures in which atoms are used. This will provide us it will provide us 3D image of the thin film. Also, by using this, we can also make some manipulations in our sample. So these are some of the calculation of the weight calculation for zinc oxide and magnesium oxide thin film with different compositions. Now, these are the results of our analysis. We can see the before and after images of the sample of the thin film. This is the result of the XRD diffraction pattern. In this, we can see what all elements are present in our thin film, like zinc oxide and magnesium oxide was present. And as their composition increase, we will see more intense peaks are present. Like at a higher presentation of magnesium oxide, we can see more intense peaks at 111 and 200. This is the result of scanning electron microscope. It basically, we will see the unevenness of the surface, as we know that the grain structures of different sizes and shapes are present. And we will see that as the magnesium oxide content increases, the grain density of the thin film will decrease, thereby providing us more even surface. Now, this is the result of EDS. In this, we will see what all elements are present in our thin film. Like we can see that zinc is present, oxygen is present, and magnesium is present. And we'll also see that no other element was present during the study. This is the result of atomic force microscopy. And in atomic force microscopy, we will see the basically, we will see the roughness of the thin films. We'll see as the surface texture angle increases, the roughness of the thin film will also increases. We'll see that there are different structure of grains are present on the thin film, which have different shape, like they have rounder shape, they have columnar shape. But as the content of magnesium oxide increases, the grain, the unevenness of the thin film will reduce as the larger grains will consume the smaller grains will be consumed, and the evenness will also occur due to the presence of both the phases of on the thin film, like both hexagonal phase and both cubic phase are present. Later, this is the graph between between grain size and magnesium oxide content, where we can see as the magnesium oxide content is increasing, the grain size is also increasing. This is the graph between the absorption coefficient and the wavelength for different composition of the thin films. Now, this is the result of the graph between the magnesium oxide content and the different band gaps. We can see as the magnesium oxide contents are increasing, the band gaps are also increasing. This is due to the Mosten-Bruce effect, in which there is a blue shift in the blue shift of the absorption spectrum in the ultraviolet region. So these are the conclusions. That thin films of different composition on silicon substrate and glass substrate are deposited using electron beam method. We will use different analysis method in order to find out their structure. We are using XRD, we are using SEM, we are using AFM analysis. So these are the publication details I have done on the study, and these are the references. Okay, thank you.
Thank you, ma'am, for
So, good evening, all of you. Myself, Diksha Ratan. I have done my work on region-based segmentation with hybrid classification method, plant diseases. And I have done my work under my supervisor, Dr. Jasveer Singh. So, I'll start with introduction. As we know, farming is a major human movement that helped mankind to progress and build. Farming sector is a main pillar of economy to diverse emerging countries. In general, agriculture acts significantly the commercial progress of India. Any harm to the harvest causes great loss in the productivity, which has the great impact on the progress of the nation. And the diseases signs are depicted on the leaves of the plant in initial phases. The development of plant defines the quantity and the quality of the crop productivity. Therefore, the detection of the disease occurred on the leaves of the plant is required at the primary phase. When the disease is detected, some essential steps may be taken for preventing its spread. Disease plant effects may include as leaf spot, leaf curse, root damage, natural product decay, natural product spots, dying and declining. And the next one is plant detection diseases. In agriculture crops, leaves act significantly for offering information related to the amount and the nature of the horticulture yield. And the productivity of the food is affected due to the various factors, including climate changes, occurrence of weed and soil infertility. Another factor that has a great impact on the productivity of the food is the occurrence of disease in the plant leaf, due to which progress of various agriculture products are affected. Then plant diseases is based on deep learning, and it is divided into the three sections: classification, detection, and segmentation. Classification in actual norms scenario, extraordinary contrast in size, shapes, surface, color, foundation, design, and imagining. Light of the plant diseases and warm makes acknowledgement a troublesome undertaking. Then we have detection. Location of object is probably the most important work in the field of PCA vision, that is principal component analysis, which reduces the dimensionality in the machine learning. Then we have segmentation. It is reduced and responsibility for converting the function of plant disease detection into the semantic. Then we have plant disease detection based on the CNN. Convolutional networks belong to the family of neural networks. CNNs have proved that efficiency of in the fields of the image recognition and the classification. Coordinates have been successfully applied for the recognizing face, objects, and traffic signs, in addition to strengthening vision in robots and automatic vehicles. Then we have image acquisition. It is divided into basically plant disease detection based on CNN is divided into the 5 parts. The first one is image acquisition. In this acquirement of different plants imaginary from different data sets, one data set is the plant village data set. Then we have pre-processing. It decides the performance of the model. It is quite challenging to different viral, bacterial, and the fungal disorders. It is divided into 2 parts. The first one is augmentation. It improves the journal efficiency of a model and different functions, including zoom, rotate, adding color changes, etc. And then the second part of the pre-processing is transfer learning. Transfer learning technique has also performed extraordinarily with the smaller data sets. It provides superior outcomes. And then we have segmentation. The process of separating a leaf from its background, in this the segmentation is doing. And feature extraction, generally color, contour, texture, and the shape of a plant leaves are used for classifying plants. The grayscale image transformed into the binary image by binarization, and then a contour is extracted. Then we have classification by CNN. It is divided into the 3 stages. The first one is trailing of image size. Testing of image size ranging from 115 to 150 to 255 into 255 is performed. Then we have optimization. The ResNet 34 model is optimized by the most appropriate image size residual networks, making it possible to construct the networks with up to 1,000 of convolution layers. Then we have visualizations. The model is devised for creating a web application. This is carried out by storing the completed essential files in GitHub. Then we have literature surveys, and in the then we have problem formulation. In this, the detection of plant, the main challenge is the recognition of the infection on the plant leaves. The process consists of the three stages: pre-processing, feature extraction, and the classification. In pre-processing phase, the image will be deionized, and then the second step, the textual features will be taken out from the GLCM algorithm. In the last step, a multi-SVM classification model has been implemented to classify the infections. SVM has two main shortcomings causing drop in efficiency of the system. Then we have SVM classifies data on the basis of hyperplan, which surges the complexity of the configuration. Then we have objectives. The first objective is to perform plant diseases detection by applying GLCM and SVM algorithm approaches. In this, detection is performed using machine learning, which classifies disease into two classes. Grayscale co-occurrence, that is GLCM, is a textual features extraction algorithm that can retrieve features for the classification. And the SVM classifier will define the class based on the retrieved attributes. Then we have second one is to design a hybrid classification model of plant disease detection. The objective is concerned with designing an original classification framework model for plant disease detection. GLCM algorithm is used for feature extraction and hybrid classification model for data classification. Third one is applying the developed method. Applying the developed method with respect to accuracy, precision, and recall, and comparing it with the other available approaches. Then we have research methodology. In this pre-processing, first is the first step, and the second is segmentation. Then we have feature extraction, and then we have classification. In pre-processing, the image is pre-processed in this function with the objective of diagnosing the diseases from the leaves of the plants. The plant village is a website that will be helpful for deriving the information about the plant and its disease kind. The image taken from wheat are involved in the datasets. This dataset consists of three portions, in which images normal leaves, leaves suffered from early blight, and the image of the late blight diseases are inserted. The process also focuses on transforming the image into the grayscale. Then the second one is segmentation, which the process of segment and image is adopted to identify the objects and retrieve the information from the images. Then we have this technique of segmentation is an image is put forward to locate the ROI and bounding line of pictures. Then we have feature extraction. In this, function is carried for retrieving the attributes from the required region. Then we have classification. There are two sections of data. That is that the first one is training and the second one is testing. In training, images will be taken as an input and features will be extracted and saved in the database. And the next phase in the test training is k-means segmentation is applied for the segmentation. After that segmentation, GLCM algorithm is applied for the feature extraction. In testing section, the single image will be taken as an input and features will be extracted and saved in the database. Voting classification method is applied for the disease prediction. And the performance analysis is done in the term of precision, recall, and accuracy. Then we have this research methodology. Then the results and the discussion we have. Plant diseases, plant village dataset is employed to implement the introduced technique. It is a public dataset in which information about plant infection is comprised. The first is the dataset description. And using plant village dataset experiment is performed on the developed model. It is an open source. Information of plants and infection is comprised. Each image is tagged with its diseases. Then we have precision comparison and the recall comparison, in which we can see existing method have had 94 point something percentage, and I have done the best in the proposed method with the 97.5 something percentage, and in the recall comparison it's the same. And in accuracy comparison, it indicates that the introduced system outperformed the existing system concerning accuracy value. And then we have conclusion. This work concludes that the introduced approach is applicable to diagnose the diseases. Our technique detects the infected plants in the diverse method, and the k-means is adopted to segment the plant image, in which law textual technique is exploited. The disease is predicted using RF random forest and the decision tree algorithm, and comparative analysis is conducted on the introduced approach against the SVM. The introduced approach offers more effectiveness in the comparison with the conventional technique, accuracy, precision, and recall to detect the infected plants. Then we have the future work. The processed model can be extended using method of transform learning, and the processed model can be compared with the machine learning models for the plant disease detection. That's all from my side. Thank you.
Thank you, Diksha, for your wonderful presentation and good results.
Good evening, one and all present here. My name is Komal Sharma, and I am pursuing Masters of Technology at Punjabi University, Patiala. So the title of my presentation is Pixel Weight-Based Approach for Image Enhancement with Kernel Function. So the flow of my presentation will be like, firstly, we will have the introduction, then existing techniques, and so on. Introduction. As we all know that technology plays a vital role in all spheres of human life. It can be smartphones, smartwatches, medical images, etc. And we are on the roads of digital transformation. So there is a need of maintaining the quality of digital images, which in turn leads to various image enhancement techniques. And the major portion of the earth is covered by water. Therefore, the study of aquatic environment is gaining a lot of attention. As we know that underwater images not only unravels the mystery beneath water, but also provides information required for underwater scientific studies, such as understanding marine ecology, assisting aquatic robots, etc. As we all know that taking underwater images, and mostly underwater images are of poor quality with greenish blue appearance. For example, what we can say that if the image is captured in a medium where the algae content is high, then the color cast of the image will be greenish. And if the image is captured in a deep of water, then the color cast of the image will be bluish. So there is a need of maintaining the actual color cast of an underwater image. Image processing. Basically, it is a method to convert an image into a digital form. So these are the steps. Firstly, we have the image acquisition. So this is the very first step to acquire the image or to obtain the image. Next, we have the pre-processing. After that, we have the segmentation in which we divide the picture into elements and entities. After that, we have the representation in which the data is represented as a whole or as an edge is made. The choice is made. And after that, we have the knowledge base in which the all information regarding all the levels is given. So these are the image fusion techniques. IHS, basically intensity hue saturation transform, is a method to convert the RGB image into a IHS space. This is mainly used for sharpening the color image. And next technique we have here is pyramid technique. Basically, in this we use a blurring filter, and it is followed by a downsampling for reducing the size of the image. After that, we have the high pass filtering method, in which we combine the high resolution information in the black and white image with the low resolution information in the colored image. Next method we have here is principal component analysis, where the pixel values are modified to achieve the final resultant image. So these are the various image enhancement methods like histogram equalization, brightness preserving by histogram equalization, adaptive histogram equalization, contrast limited adaptive histogram equalization. Basically, we use these methods to enhance the images so that we are able to extract the good quality of an image. Problem formulation. The multi-model image enhancement is the purpose of enhancing images while taking protection of image details. Basically, this model decomposes the image layer-wise. Like, firstly, we have the small layer, then we have the base layer, then we have the large layer. At the small layer, maximum absolute values of fusion rules are considered, and at the large layer, weight-based fusion rules are derived, and at the base layer, decomposition is done, which is based on the activity level measurements. At last, we are going to merge all the layers so that we are going to have a final enhanced image. Basically, this technique has two research gaps. One is loss of information and second is complexity. So we need to design a proposed technique which can reduce the information loss and accurately design weight-based rules. So the major objectives are to generate a natural colored image which is of high contrast, and to study various multimodal image enhanced techniques. Third is to implement weight-based fusion rules. And fourth is to design the approach so that we are able to get the accurate design of weight-based fusion rules. And fifth is to implement this approach and compare it with existing in terms of certain parameters. So this is the research work. Firstly, we are taking the input image, which is of low quality. And after that, the second step is we are going to check the pixel weight, which is based on the pixel intensity. And after that, we are going to select the kernel size. And next step is identify the noisy image from the selected window. After that, input the window size, image, and similarity factor. And at last, remove identified pixels from the image. So this is the overview of fusion-based underwater image enhancement. What we are going to do is we are taking the two input images, which is of low quality. Basically, these are the underwater images. After applying pre-processing technique on both the images individually, what we are going to do, we are going to apply the image enhancement algorithms on both the images separately. And at last, we are going to fuse both the images by using an image fusion technique. And after reconstruction, we get the fused image, or we can see the merged image, which is of high quality, which is of enhanced quality. So these are the results. Basically, these are the input images and these are the output images. After applying this method, what we are going to have is we are having the output images which are of high quality. As we can clearly see that from these images, we are able to extract more information as compared to the input images. So we have analyzed this in terms of certain parameters. First is MSE analysis, or we can say the mean square error. What we can see that in the proposed method, the value of MSE is less as compared to the existing method. So it means that it has less number of errors as compared to the existing method. So next parameter we have here is PSNR, or we can say peak signal to noise ratio. What we can say that is in proposed method, we are able to have the high value of PSNR as compared to that of the existing method, which means that our image is of high quality and it has high contrast. Conclusion: the underwater images lack color contrast and appear dull or misty due to various factors. It can be absorption, it can be scattering. So there is a need of maintaining the actual quality of the image. So we have formulated this algorithm for the enhancement and restoration of the underwater images. And this proposed method gives us enhanced images, not only in terms of visual appearance, but also in terms of quantitative measures, as we have seen with the PSNR and MSE analysis. So this is the future work. The proposed model can be compared with image enhancement algorithms, and deep learning model can also be applied. And these are the references. Thank you.
Thank you, Komala, for your wonderful.
Myself, Kishore Bagaria. My topic is the effect of hydrogen addition in soybean biodiesel on the performance of a single cylinder diesel engine. Can my screen is visible, sir?
Yes, sir. Yes, sir. It is visible. Sir.
Oh, thank you, sir. Thank you. So my topic is effect of hydrogen addition in the soybean biodiesel on the performance of single cylinder CI engine. Now, in this present work, the hydrogen enriched soybean biodiesel was considered as the working fuel for the CI engine. The effect of different blending percentage of the soybean oil in the diesel with hydrogen addition was experimentally analyzed during my work. In order to analyze the effect of different blending percentage of soybean, I use here 5%, 10% and 15% volume percentage was considered during my entire work. As hydrogen enrichment affect the performance of the biodiesel and the effect of change in the percentage of the hydrogen addition was also considered during the work with each blend of composition. The result shows that adding hydrogen to soybean biodiesel increases the performance to a certain extent. The variation in the hydrogen addition into the biodiesel not only affect on the performance of the engine but also affects on the emission content, which is the most useful para for us. Introduction. In internal combustion engine and other traditional forms of fossil fuels are extremely important components of today's transportation and the power systems. Now today we are all of are being using this internal combustion engine in which we are using the fossil fuel as our main fuel. In particular, diesel engine are still widely used in the field of power generation owing to indisputable benefits they provide, including the high power to weight ratio and the values of efficiency. Now, according to the forecast made by the United States Energy Information Administration, the world non-renewable and the finite petroleum reserves would have been depleted themselves by 2050. So we should move towards the alternative fuels. For that, we have considered here, I have considered the different fields. Studies on the reduction of the pollutant increased by the diesel engine are another major problem that needs to be comprehensively handled by the scientists. Unwanted exhaust emission from the engine, such as the smoke, unburned hydrocarbons, carbon monoxide, fine particles, and the NOx, have a harmful effect on the health of living being and the environmental weather conditions. Alternate energy sources such as the biofuels have the potentials to completely replace the traditional fuels like the fossil fuels. They provide a number of benefits, including the renewability, sustainability, a decrease in the emission of the greenhouse gases, and the regional development, and amongst the other things. Biodiesel stand out above all the types of the biofuels due to the fact that it has many of the same fuel qualities as the diesel fuel, which enables it to be used with the very few or even no change made to the engine. When compared to the petrol diesel fuel, biodiesel has a number of advantages, including the non-containing sulfur, being oxygenated, being ecologically responsible, having a high flash point, which is the important for the storage point of view, being biodegradable, producing the pure emission, and have a variety of feedstock opportunities for the production, including the vegetables, algae, microbial, and the waste oil as well as the animal fats. Here, in this work, soybean biodiesel gets enriched with the hydrogen and measures the different performance and the emission parameters. The effect of change in the soybean oil percentage with the hydrogen addition was also evaluated during my entire work. Though experiment it was found that addition of the hydrogen and the performance of the CI engine get enhanced with the 10% blending, it shows maximum performance and the lowest exhaust emission outcome. Now the experimental methodology used by me is, though the transformation method, soybean biodiesel was synthesized in the laboratory of Apex Innovation, Sangli, Maharashtra, India, which was the basic fuel was employed for the experiment. For the purpose of conducting the experiment, total 6 different fuel samples were to be prepared. First one is the bare 5% blending of the soybean, second 5% soybean plus 5% hydrogen, third 10% soybean, fourth 10% soybean plus 10% hydrogen, fifth is 15% soybean oil, and last one is the 15% soybean plus hydrogen oil. So such 6 fuels are being prepared, fuel samples are being taken for the comparison. Now the engine which have been used, the engine details are being described here, and the figure is also being shown in the sketch. For performing the experimental combustion of the different biodiesel, single cylinder CI engine was used. The specification of the engine was considered during the experimental is mentioned here. IS engine setup under test is the research diesel engine having 3.5 kilowatt at 15,000 RPM, which is a per cylinder engine. Per cylinder 4-stroke constant speed water cooled diesel engine with the bore 87.5 mm stroke 1110 mm. Now the results and the discussions under this, the first parameter which has been analyzed is the brake thermal efficiency. Total 6 types of the fuel samples are shown in the figure by the different colors, each with their own unique range of brake thermal efficiency. In general, the brake thermal efficiency rises with the increase in the load and reaches its highest point somewhere close to 30% of the load. This is because all the fuel samples exhibited superior combustion under the greater load which those load are applied. It has been shown that increase in the brake thermal efficiency up to 4% may be seen in continuously across all the loading circumstances when hydrogen is present with the diesel as the pilot fuel. Figure shows brake thermal efficiency for the different bending compositions with and without hydrogen enrichment. In this, you can see the yellow line, that is the 10% hydrogen. This gives us the more efficiency. Also, the yellow line which has been shown for the 15% also at the 16 load is also gives us the highest efficiency. Now the mechanical efficiency. Now in this figure, it was found that with the addition of the hydrogen to the different blending composition of the soybean oil, efficiency get increased. With increasing the loading condition, the mechanical efficiency get also increased, which is further get enhanced with the addition of the hydrogen. Though the experimental overall, it is found that 5% average improvement was reported in each case of blending due to hydrogen addition. If suppose we are using the only the soybean, instead of using only soybean, if you are adding the soybean with the diesel, we are getting the averagely 5% increase in the efficiency. With 10% blending of the soybean oil and the hydrogen addition, that is the 10% hydrogen, shows the maximum efficiency as compared to the other cases, as shown by the yellow line in this figure. Now, third parameter which has been analyzed is the specific fuel consumption. A vehicle specific fuel consumption may be thought as a measurement of how efficiency of engine uses the fuel to accomplish the productive work. The change in the specific fuel consumption in relation to the load is seen in the figure, and it relates to the various test fuel samples. The most cases, an increase in the load results in the reduction in the total amount of the gasoline used by the vehicle. This suggests that increase in the fuel consumption related to the increase in the load is lower at the greater load owing to improvement in the combustion. Now the last parameter which is analyzed is the emission. That is the most important parameter as far as the any engine is considered is the emission. So here I have shown the three main parameters. First is the carbon monoxide, second is the NOx, nitrites of oxygen, and third one is the hydrocarbon. In this all three figures you can see as the highest load we will get the lower emission if we are using the hydrogen as the hydrogen and the 10% soybean. Because of the inefficient combustion, relatively rich mixture that have to be met to the greater load, amount of CO that is emitted increases as the load is to be increased. Because hydrogen and biodiesel are present, there is a less carbon monoxide released into the atmosphere. The first one contributes to the improvement in the combustion sorry, by burning itself, while the second one contributes to the improvement of the combustion by delivering the extra oxygen. The variation of the oxides of nitrogen with respect to the load for the different fuel sample is shown in the figure, which can be found below. It was discovered that the oxides of nitrogen increase as the load did for each of the fuel test sample were to be evaluated. It is possible that this is the consequence of the combustion of a greater quantity of the fuel that was delivered into the cylinder in order to fulfill the load requirements. According to the finding, 10% sample, 10% hydrogen sample has a SC, that is the hydrocarbon emission, that was 6 to 9% lower than the other samples without hydrogen enrichment. One possible explanation for this is that hydrogen has the quicker rate of combustion, which is in it serves to enhance the combustion. Now the last conclusion, in contrast to the biodiesel, 10% hydrogen was the most effective of all the fuel, increasing the power by 6.64% while simultaneously decreasing the specific fuel consumption by 6%. Because some of its inherent properties, such as the lower calorific value, cetane number, as well as greater viscosity, the use of soybean biodiesel has the effect of degrading the performance requirement of the engine. It is possible to restore and improve the engine performance, which may have been imparted due to the use of biodiesel with the assistance of hydrogen addition. The use of biodiesel and the hydrogen has contributed to the reduction in the CO emission in contrast to the CO formation. Biodiesel resulted is an increase in the emission of the CO2. The addition of the hydrogen has also contributed further to the creation of the CO2 instead of CO, that is the carbon monoxide. Thank you.
Thank you, sir, for your wonderful presentation. So how will you be mixing hydrogen in a liquid form to biodiesel, or like how is it, sir?
Sir, for mixing the hydrogen, the separate machine has been used. In that, per part minute, hydrogen is been enriched in liquid form.
Okay, okay. So in ppm, you are mixing it with this. It is
With the diesel. With diesel.
with the diesel. Differently, it will be coming. Two different equipment will be coming into the combustion chamber for the test, or like
In the combustion chamber, a separate pipe has been introduced at the right side, from which the measure quantity of the hydrogen is been added.
Is it like it is not pre-mixed with diesel, biodiesel?
No, not pre-mix. Added separately, just before the entry to the combustion chamber.
Just before the entry to the combustion chamber.
Yes, sir.
Wonderful, sir. Good thought and a nice presentation. So it will be in the hydrogen gaseous manner or liquid?
No, in liquid manner. In liquid, sir.
Hydrogen liquids are quite costly.
Because the here we are using the inverted cylinder, so the liquid has been converted into the liquid, sir. So that there is a very less risk.
Hydrogen liquids are quite costly.
Yes, sir. It is costly, but very little amount has been required here for experimentation.
Okay.
Because if you are using in the gaseous state, then the more precautions are to be care for handling it with the vehicle. That's why in the liquid form it is in use for the experimentation.
Thank you, sir. Thanks for your wonderful presentation, sir. Nice to be in touch with you. Please share your email address, sir. We'll be in touch. Thank you.
Can everyone see my screen?
Yes, yes.
So the topic of my research paper is augmenting visual thinking for accelerated learning through disruptive visual works during COVID-19 pandemic. To start with, we are going to be discussing introduction, background of the study, research objectives, literature review, method, data analysis, and conclusion, then future scope and end references. So for the introduction, this study puts forward the role of cognitive spheres and multiple intelligence. Multiple intelligence is a concept shared by Howard Gardner, which is that any human has 8 types of multiple intelligence, which are linguistic, logical, mathematical, musical, interpersonal, bodily, visual spatial, naturalistic, and interpersonal. And for and special emphasis are going to be paid on visual spatial intelligence, can raise awareness and create impact on linguistic intelligence and bodily kinesthetic intelligence in the domain of learning and development during COVID-19 pandemic. So background of the study, COVID-19 brought a disruption in conventional method of knowledge dissemination as interpersonal connection moved from this physical to virtual completely, as we are sitting right now. Role of visual spatial intelligence increased multiflow in instruction sessions, teaching sessions, and in co-creation of information dissemination sessions. So for research objectives, we are going to be putting forward the scenarios where these disruptive visual works have been put in practice and create impact on information distribution and co-create solutions to different scenarios. So if you look closely on this side of the screen, on the right hand side of the screen, we are actually confirming this is actually a graphic recording session. And in this session, what we usually do is while a session is going on, a graphic recorder is going to be standing right next to the and is going to visually record everything that has been discussed in the seminar, so that afterwards we can sit and discuss over the same. Again, this is a graphic recording session that I did with IF, the International Association of Facilitators, from doing facilitation to being facilitation. So for literature review, it is said that to separate visual information from traditional alphabetic information is short-sighted when considering the opportunities provided to libraries and their patterns with advancing technology. So what the diagram right here is suggesting that when we discuss with text or when we read and try to learn with text, it's only 10% retention. With picture, it's up to 35% retention, and text and picture combined is up to 55% of retention. Again, another model that we'll be discussing is Vikri's interpersonal information work. It depends on three components, which are science, technology, and art of participation. And when we combine all of these together, it's triple law of information. So for research methodology, a workshop was carried on. At the end of the workshop, a questionnaire was distributed, and roughly we got 75 participants to fill up the form, which included engineers, healthcare professionals, educators, facilitators, teachers, students from different domains and fields. So the questions which the questionnaire consisted of: can you make a simple drawing? Out of 75 participants, yes, they were aware how to make a simple drawing, which were around 30, that is 40% of the participants. Second question consisted of, do you know what basic shapes are used to make a drawing? 61 participants says, yes, they are aware of basic shapes, like let it be triangle, rectangle, straight line, circle, or anything. Third question was, what is the level of your drawing? I mean, if I want to convey it to anyone on the audience right now, what do you think? What is the level of your drawing? Are you a beginner or you are like an acceptable level? So 52 people said that they are at a beginner level. And the last one was, are you aware of the term visual metaphor? So most people, around 62 people, were aware of the term visual metaphor. That is visual to show a situation differently but relatable to this man. So the finding was, random survey indicates that only 40% of people can make a simple drawing. Reason is out of habit or practice. 81.3% of people are aware of basic shapes used to make a drawing. Reason was, everyone starts learning by using basic drawing elements at a very young age. 30.6% of people stated that their drawings are of acceptable level. The reason of it being so low is because we are afraid of being judgmental, like what everyone is going to think of our drawing. So drawing are subjective and put under judgment by the viewer. And 82.7% of the respondents said that they're aware of a visual metaphor. So conclusions, visuals need to be an integral part of information dissemination and experience during COVID-19 pandemic. Collaborative process which need to be agile require visual components for better understanding. External visual practitioners can be a part of information processing during knowledge session, and their presence could be virtual or physical as well. Future scope of the study is visual facilitation is needed to be a part of learning as catalyst for purpose of making learning creative, holistic. Critical thinking is a very good point, and participative. So some of the DVWs that are discussed on the drawing picture right here are visual storytelling, sketch noting, doodling, graphic recording, visual harvesting, and generative scribing. These are the list of references. And thank you. This was
Thank you, Manu, for a wonderful presentation. Nice to see a good presentation as well as a good topic. We'll collaborate. Please share your email address in the chat box. Thank you.
Thank you for inviting me to this conference. And my name is Åke Stenholm. I'm working in Sweden in Uppsala University, and my research area is fungi. And I have investigated fungi for biodegradation of toxic substances. And in this case, I have worked with neomycin, which is an antibiotic. And the problem with antibiotics is, as you know, other recalcitrant compounds, that is compounds that are easily biodegradable, that they are leading out in effluents to the recipients. And the recipients here, there are the rivers, the lakes, and the compounds, they go right through the wastewater treatment plants, and they are not biodegraded by the bacteria in the biological treatments. So we have an issue with these compounds. And the scope here is that I investigated whether selected fungal species can be used to biodegrade neomycin. And what is neomycin? It's an aminoglycoside, and it was invented in 1949 not invented, but it was discovered and is used mainly in veterinary medicine. And sometimes it's used for as a preventive medicine. In some countries it's not allowed, but in many countries it's used as a preventive antibiotic. And it's mostly excreted unmetabolized, and therefore it's present in wastewaters. And if you look on the molecule, you can see that it doesn't have any chromophores, and furthermore, it's positively charged in the wastewaters and in the recipients, and therefore it's very tricky to analyze it. You cannot use UV, for example. There, you are obliged to use mass spectrometry. All the investigations, analytical investigations that has been performed, they use mass spectrometry. And when you work with the biodegradation of substances, often in the studies they use so-called co-metabolism. It is when the biodegradation of a toxic substance is performed in the presence of external nutrients. As you can see in this scheme here, the nutrients which are external, it can be, for example, glucose, ammonium, tartrate, which I have used. At the same time, however, the toxic substance can be biodegraded by the fungi without any use by nutrients. Normal-wise, the fungus there are extracellular enzymes present from which are secreted by the fungus, which can biodegrade these recalcitrant compounds, but sometimes they are actually used by the fungus as nutrients. In my investigation here, I used two fungal species. One is the Trametes versicolor, which is extensively investigated. It's a white rot fungus. And then I used a mycorrhizal species, which lives in symbiosis with some plants. And these are not the fruit bodies I have investigated, but the mycelia of the fungi. And the investigations were performed in Erlenmeyer flasks. And you can see on these pictures here that the Trametes versicolor, it was immobilized on polyurethane foam pieces. And the reason for that is that you can get better enzymatic activities, and you can also decrease the bacterial influence of bacteria. However, the other species was not easy to immobilize. Therefore, you can see to the right, it has no polyurethane foam cubes in it. In the center, you can see it's part of the results. You can see that when you just have the fungus without any external nutrients, you get some color effects showing that it's not compatible. Here's the design of the experiments. When you can see the NS, it stands for the external nutrient solution. And when you don't have the NS, it's pure neomycin. So in this design of experiments, you can see that I used both nutrient solutions and without any nutrient solution. So I investigated whether the fungi could biodegrade neomycin with or without this external nutrient solution. And concerning the analytical equipment, I used liquid chromatography coupled to high resolution mass spectrometry. And because it is really the best solution, the best solution to analyze this compound. Something about the results here. You can see the biodegradation curves to the left, where you have the hours on the x-axis and the concentration of neomycin on the y-axis. And you can see that here is for the Trametes versicolor, the white rot fungus. You can see that for the 4 last curves, you cannot really see, or the last 3, you cannot see any decline in the curves. And that means that, well, the fungus is not, it has not the possibility to biodegrade neomycin in the absence of the external nutrient solution. As a matter of fact, it cannot survive on it. If you look on the right side here, you can see that you have the removal degree, and it's the highest for one of the experiments where I use the nutrient solution. And for the ones there where you have solely the neomycin, you can see that for one of them you get a 25% removal degree, but we think that it's because of some residues of the nutrient solution in the experiment. However, you can see that experiment is this one where you can see it has a sharp decline in the beginning, but then it stops. Concerning the other fungus, you can see on these graphs that this fungus have the possibility to biodegrade the antibiotic neomycin without any external nutrients. So the conclusion is that this species used neomycin as nutrient. It can thus survive on this fungus. And when I come to the conclusions here, that is that the biodegradation of neomycin immobilized using polyurethane foam, immobilized Trametes versicolor is accomplished by co-metabolic conditions where I use the external nutrients. And furthermore, the removal degree was dependent on the concentration level of these nutrient solutions. And one major conclusion is that this fungus cannot survive on sole neomycin. On the contrary, the mycorrhizal fungus Rhizophus erica can survive on sole neomycin. And why is this important? It's, I mean, if you want to use fungi for biodegradation purposes, it's very convenient if you can exclude the external nutrients, because it's a matter of costs. And so in further studies, we will examine other fungi that can survive and grow on toxic substances. Thank you very much for your attention, and that's all.
Thank you, sir, for your wonderful presentation.